When bacteria land on a surface, they grow and multiply, clumping together and forming a continuous layer which is difficult to remove. If we touch that layer, we pick up some of those bacteria and then we pass them on when we touch something else, maybe touching our mouth or touching another surface. This is a big problem in places where we need to prevent the transfer of bacteria, such as hospitals or food factories. Regular cleaning helps reduce the problem. So we wash our hands, we wash the equipment we use, but there's still a big infection risk with high-touch surfaces that don't get cleaned all the time, like switches, door handles, and hospital bed rails. We're working on new ways to create antimicrobial surfaces that kill bacteria before they can grow and spread. We're creating new coatings for surfaces which put bacteria into contact with tiny particles with antibacterial properties. These particles can kill bacteria in different ways, such as breaking up the cell walls or disrupting their metabolism. The key concept we're working on is how to make sure these nanoparticles end up on the outer surface of the coating as it dries, to maximize its efficiency. In a conventional coating, there are particles of different sizes in the solution that is painted or sprayed onto a surface. And when this dries, these particles are all mixed up randomly. So if we added our antibacterial nanoparticles to a conventional formulation, they would get mixed in as the coating dries. With most of the nanoparticles sitting below the outer surface, bacteria are more likely to grow and multiply. In our coatings, particles arrange themselves by size as the coating dries, so that the tiny antibacterial nanoparticles are at the top surface. This creates an effective antimicrobial surface. Bacteria that land on the coating are killed by the nanoparticles. So, by applying our coatings to high-touch surfaces, we will help to stop the spread of infection.